Hello, welcome to this walkthrough of Mastery Exam EL, Practice Version 1, problem number 3. Here we're asked to write the following expression as a single logarithm, negative log base 2x plus 3 log base 2 of y minus 2 log base 2 of z. What does it mean to write something as a single logarithm, first of all? That means I'm going to have to simplify this expression that involves 3 logarithms with some addition and subtraction and some number multiplication between them, and simplify it down to where it's the log base 2 of a single thing. That's what it means to write as a single logarithm. I'm going to have to apply some rules to get there, and there are 3 rules that really work in this situation that get us to where we want to go. Let me just write those out over here on the left. One rule is that the log base a of x plus log base a of y, when I'm adding 2 logarithms together, I end up multiplying the results. There's a similar rule for subtracting logarithms. Log base a minus of x minus log base a of y is the log base a of x divided by y. So adding 2 logarithms results in multiplying the arguments in a single logarithm. Subtracting the logarithms becomes dividing the arguments inside a single logarithm. This is true because logarithms are the exact opposite or the inverses of raising things to powers, to exponentiation. And we know that if I had, for example, let's just write this up here, like a to the x times a to the y, where I have 2 exponential expressions, and multiplying the exponents results in, or exponential expressions results in adding the exponents. And this is just the reverse of that. Adding the logarithms results in multiplying. Likewise, subtracting logarithms results in dividing. There's one last rule here that's particularly important. Log base a of x to the r power, taking the logarithm of something to a power, results in the power becoming just merely a multiple, like so. So I'm going to box these off. These are fairly important. In fact, they're central to understanding how to work this particular problem here. Just leave that over here. Now let's work with this expression here. I'm going to first, oops, I still got my box here. Let's erase that. I'm first going to work with each part of this expression here, individually, especially the ones that have numbers in front of them. Let's do that first. So I'm not going to do anything with this negative log 2x. Log base 2 of y with a 3 out in front of it, that looks a lot like the right-hand side of this expression right here, 3 log base 2 of y. And so what the property says is that this is going to become the log base 2 of y to the 3rd power. So the 3 being multiplied to a logarithm becomes an exponent on the argument. Likewise, this 2 multiplied to log base 2 of z, that's going to turn that into log base 2 of z to the 2nd power. So now I have no numbers multiplied to any of the logarithms by using this 3rd property over here repeatedly. I think we're in a position now to start reducing things down. Let's just take 2 terms at a time. Let me focus, for example, on these first 2 terms. How can I simplify those things? Well, I'm really subtracting here. It may help to reverse the order of these 2 terms just so you can see the subtraction. This is log base 2 of y cubed minus log base 2 of x. And just keep rewriting this. We're not doing anything with it yet. Now here's a situation where I'm subtracting 2 things. It's this middle property that's going to work for us here. The log base a of, or log base 2 of y to the 3rd minus log base 2 of x. That's going to become the log base 2 of a division, okay, y cubed divided by x. I'm also still subtracting this log base 2 of z squared. So again, that was using this middle property here. And you see what's left over is another usage of that middle property. I have 2 logarithms with the same base, 2, and they're subtracted. So here's where my final answer is going to come from. I can now write this down as a single logarithm, namely log base 2 of y cubed over x divided by z squared. A better way to write that would be this, log base 2 of y cubed over x z squared. I think either one of these would be acceptable. This is better in terms of having simplifying things completely. But we have written the expression as a single logarithm, so either of these two things is correct. The important thing is to realize that we're using the rules repeatedly to get from a string of logarithms with multiples and addition and subtraction down into one logarithm with a single argument. We didn't use that first rule in this particular problem, but in other mastery exams that could certainly come up as well.